Jai Hind everyone, myself Akgec Dubey, Assistant Professor in Department of Mechanical Engineering, Ajay Engineering College, Ghaziabad. Today I will discuss the topic moment of inertia, which is very useful for the mechanical engineering as well as for the civil engineering student. This topic is very important for the subjects like strength of material, engineering mechanics, design, dynamics of machine, in which balancing of rotating masses is done. This topic is also important for the GATE and other competitive examination point of view. We study MI in two ways. One is the mass moment of inertia and second is the second moment of area, also termed as moment of inertia or area moment of inertia. Let us see what is the moment of inertia is. It is made up of two words, moment plus inertia. Moment has its own meaning and inertia has its own meaning. If I will combine these two, we will come to the conclusion what the moment of inertia is. Here I will write moment of inertia. Moment. It is nothing but the measure of rotational effect of a force about a point. This is the meaning of moment. And inertia, it is the resistance against the change of state. If I combine these two words, I will define moment of inertia as it is the measure of rotational resistance offered by the mass about the axis of rotation. And this resistance to rotation about an axis varies depending upon the shape of the body or the distribution of mass with respect to the axis. Mathematically, moment of inertia, how it is defined. So, let us assume a elemental mass dm. It is situated at certain distance from the given axis. Say this is x axis and this is y axis. The distance of this mass from the x axis is y and from the y axis it is x. If I want to take the moment of inertia of this elemental mass about x axis or about y axis, so I will write this as Im. M stand for mass here. I already told you about the it is studied in two ways. One is the mass moment of inertia and one is the area moment of inertia. Here I am discussing about the mass moment of inertia, that is why I am putting the suffix m. So, Im x means moment of inertia about x axis. It is integration y square dm. And if I consider y axis, it is Im y and this is integration x square dm. This is the mathematical representation of moment of inertia. Further, I will discuss the moment of inertia of certain standard bodies like rod, plate, cone, sphere, cylinder, about the different axes about which this body is want to be rotated. Another important definition regarding this topic is the radius of gyration. Radius of gyration. It is defined as the distance from the axis of inertia to the point at which the entire mass of the body is assumed to be concentrated and still have the same moment of inertia as it was of the actual body, moment of inertia of the actual body about the same axis. So, say this is the axis about which I want to calculate the moment of inertia, and say this is the body whose mass is m. If I concentrate this whole mass at a point, say at this point, and I calculate the moment of inertia of this mass about this point, I can write this as this k is the radius of gyration and this is the mass m. So, I will write I equal to m k square, and this moment of inertia is equal if without concentrating, without squeezing, if the moment of inertia, if this whole body is calculated about the same axis. Means to say, without actually compressing, without actually concentrating this mass at a point, if I calculate the moment of inertia, and after concentrating the whole mass at a point about this axis, the moment of inertia, we will get the same value of the moment of inertia. तो रेडियस ऑफ गायरेशन वो दूरी है जो कि सेम मोमेंट ऑफ इनर्शिया देगा अगर हम किसी बॉडी को एक पॉइंट पे कंसंट्रेट करके उसका मोमेंट ऑफ इनर्शिया गिवन एक्सिस के अबाउट निकालें. तो हियर k इक्वल टू I बाई m इन स्क्वायर रूट, k इक्वल टू अंडर रूट I बाई m. Now, I will calculate the moment of inertia of a rod having length L and its mass per unit length say m. Moment of inertia of a rod about centroidal axis, centroidal axis and perpendicular to rod. Let us assume a rod of length L. This is the centroid of the rod, and this is the centroidal axis, and this is also the centroidal axis. So, centroidal axis is nothing but a line passing through the centroid of the body. That is why it is termed as centroidal axis. So, let the mass per unit length is m. and I want to calculate the moment of inertia about this line, and this is nothing but the centroidal axis and perpendicular to the longitudinal axis. Yeah, perpendicular to the rod. Considering a elemental mass at a distance x from the axis, from this vertical axis, and the length of this element is say dx. So, very easily I can find the mass of this element, and this is nothing but the m dx. So, here I will write dm equal to m dx, because I have already considered mass per unit length is m. So, mass of this small length dx is m into dx. So, this is the elemental mass, and it is situated at a distance of x from the vertical axis about which moment of inertia is need to be calculated. Say this is y axis. So, mathematically moment of inertia I m y या I m y y is integration x square dm. So, what may be the limit of integration? Since the total length of the rod is L, and this is the centroidal axis, the limit of integration will be minus L by 2 to plus L by 2, because this is the midpoint. Before that, whatever distance is, that is minus L by 2, and this is L by 2. So, limit of integration minus L by 2 to L by 2. Here I will put minus L up by 2 to L by 2. Putting the value of dm, it comes out as minus L by 2 to L by 2 x square, and dm is m dx. Integrating I m y minus L by 2 L by 2 x square m dx, m x cube by 3. Integration of x square dx is x cube by 3, and putting the limit of integration. So, here m L by 2 whole cube upper limit, take 1 by 3 out of from the bracket, minus L by 2 cube. After solving m by 3, it is L cube by 8 plus L cube by 8, and this is coming out as m L cube upon 12. So, this is the moment of inertia in terms of mass per unit length. But here I will introduce the total mass of the rod, because I have considered the mass per unit length of the rod is small m. So, what about the total mass? Let us say total mass is capital M. So, I can write this as small m into L square by 12. This m into capital L is nothing but the total mass m L square by 12. This is the moment of inertia of the rod about the centroidal axis perpendicular to the length of rod, they are perpendicular to the longitudinal axis of the rod. If I want to calculate the moment of inertia at the end of the rod, then how will I find it? See, this is the rod of length L and mass per unit length is small m, and about this axis I want to calculate the moment of inertia. So, moment of inertia about this axis plus moment of inertia of the mass of the rod about this axis. So, I will transfer the moment of inertia about this axis. So, after doing this, I will get, say, this is y dash axis, this is y. So, I am y dash equal to I am y plus mass, total mass m into this distance is L by 2 whole square. So, actually this is based on the concept of parallel axis theorem, because these two axes are parallel. So, I can get the moment of inertia about this axis after calculating the moment of inertia about this y axis. So, I will put this m L square by 12 plus m, because the total mass m is assumed to be concentrated at this point. So, distance of the total mass concentrated at this point and this axis, it is L by 2, L square by 4. After simplifying, I get m L square by 3. So, this is the moment of inertia of the rod at the end, which is parallel to the centroidal axis. So, for today's lecture, I have discussed this thing. Further in next lecture, I will discuss about the moment of inertia of a rectangular plate and many more standard figures. Thank you.